Welcome to Lesson 1, Exploring Space with Science for Unit 1 of 5th grade Matter in Motion. In your student reader, anything that's highlighted in yellow here should be highlighted yellow in your book. Bottom left-hand corner shows you a picture of what your student reader looks like. Photographing space. A telescope the size of a school bus has been circling Earth since 1990. A telescope is an instrument that helps people see objects that are too far away to see with just our eyes. This telescope is called the Hubble Space Telescope. It circles Earth from about 547 kilometers, or 340 miles above Earth. It has helped scientists know more about the universe. The Hubble Space Telescope was the first telescope to ever be sent into space. Scientists have used it to observe objects in the night sky so far beyond Earth we cannot see them from Earth. The Hubble telescope has taken many pictures of objects in space that humans have never seen before. Following a scientific process. Scientists are fascinated by the universe. Earth is just one small part of the universe. The universe holds all of the matter and energy that exist. The universe is so large that it is hard to study. Scientists use instruments such as the Hubble Space Telescope to learn more about what exists beyond Earth. Science is the search for explanations about the natural world. Because of this, asking questions is something that all scientists do. Scientists look for the causes of what they observe in the world around them. They use evidence to form conclusions that support these explanations. All knowledge learned from experiments is part of science. Science is part of a larger cycle that includes engineering, math, and technology. This cycle is called the STEM cycle. Engineers apply scientific knowledge to create new technologies that solve problems. Math is a tool that both scientists and engineers use to capture results and communicate those results to others. Scientists use a scientific process to guide them as they answer questions about the world around them. This process provides scientists with a logical framework to work from a question to a database conclusion. Scientists have always begin with a question. This question helps scientists figure out exactly what they are trying to find out. Scientists have many questions they are trying to answer. One question is, how old is the universe? In order to answer that question, scientists need to answer many smaller questions. Scientists conduct many different experiments every year. Every year, the amount of scientific knowledge grows. The Hubble Space Telescope has made more than 1 million observations since first going into space. Scientists use this existing body of knowledge to research their question. For example, scientists know that the universe contains all of the stars, planets, and other kinds of matter known to exist. Scientists also believe that Earth formed about 4.5 billion years ago. After scientists have researched their question, they form a hypothesis. A hypothesis is a statement that can be proved true or false. An example of a hypothesis is, the universe formed earlier than Earth formed. Scientists then write a summary of the experiment they will conduct to test their hypothesis. The summary should include the basics of the data to be collected, the variables that will be tested, and the parts of the experiment that will remain constant in each trial or test. Scientists will then list materials needed and the procedure they will follow. A procedure is like a step-by-step recipe for the experiment. A good procedure will let someone else repeat the experiment exactly. Scientists also draw a scientific diagram. They do this so anyone can use the same materials and follow the same steps to get similar results. They also want to create a record of their thinking. Scientists then conduct an experiment. An experiment is a procedure designed to test whether a hypothesis is true, false, or inconclusive. As scientists conduct experiments, they gather data. Data are numbers and observations gathered from an experiment. Scientists use different tools for gathering data. The Hubble Space Telescope has mirrors, cameras, and other instruments for gathering data. The telescope takes pictures and sends them to Earth. Scientists then download those images to study. Scientists use experiments to look for patterns in data. A pattern is something that happens in a regular and repeated way. A pattern sometimes tells scientists they have discovered a cause and effect relationship, where one event or thing is the result of the other. In order to discover a cause and effect relationship, scientists design experiments in a way that shows how changes to one thing cause something else to change in a predictable way. Scientists do this in a very specific way, with variables and constants. A variable is something you change. One kind of experiment is a controlled experiment. In a controlled experiment, there is usually one variable being tested. For example, when scientists built the Hubble Space Telescope, they wanted to test how the space environment would affect the materials that made up the telescope. The space environment was the variable. The experiment also has constants. Constants are conditions that remain the same during each trial. Scientists keep certain parts of the experiment constant so that they know that only the variable they are testing causes a change. Finally, an experiment sometimes has a control. A control receives the same constants, but is not exposed to the variable being tested. The control captures the effect of unknown variables. For example, scientists had a control telescope on Earth. The control telescope was exposed to all the same factors as the test telescope in the space environment. The experiment summary identifies the variables, constants, and controls. After data has been collected, scientists form a conclusion. The conclusion uses data from the experiment to explain why the hypothesis is true, false, or inconclusive. For example, data gathered from Hubble has led scientists to conclude that the universe is about 14 billion years old. Matter in space. From its position above Earth, the Hubble Space Telescope makes observations of Earth, the Sun, and distant stars. Earth, the Sun, and stars are examples of matter. Matter is everything that has mass and takes up space. All matter is made up of tiny parts that are too small to be seen. These parts are called atoms. An atom is the smallest piece of matter that has the properties of an element. An element is a substance entirely made up of one kind of atom. There are 118 different kinds of elements. All matter is made up of combinations of the 118 elements. Both non-living things and living things are made up of atoms. Even though atoms make up both living and non-living things, atoms are not alive. Atoms are so tiny that we cannot see them. Just one grain of sand is made up of many millions of atoms. Think about a grapefruit. If each atom in the grapefruit were the size of a blueberry, the grapefruit would have to be the size of Earth. There are so many atoms in just one grapefruit that they are impossible to count. Imagine having to fill up the entire planet with blueberries. That's about how many atoms there are in one grapefruit. Atoms themselves are made up of smaller particles, called protons, neutrons, and electrons. These smaller particles are much smaller than the atom itself. Because atoms are so tiny, scientists use scale to better understand the size of an atom, its smaller parts, and how it relates to everyday substances. Scale is the size, extent, or importance, magnitude, of something relative to something else. For example, the protons and neutrons group together in the atom's core, called the nucleus. If the atom is the size of a blueberry, and you open the blueberry up, the nucleus would be too small to see. If you were to make the blueberry the size of a football field, you would be able to see the nucleus. It would be the size of a small marble. The nucleus holds all of the atom's protons and neutrons. Most of the atom is filled with empty space. The electrons are much smaller than the protons and neutrons. They are in constant motion around the nucleus. However, there are huge amounts of space between each of the electrons and between the electrons and the nucleus. Forming matter. All of the matter that exists, including stars, planets, and all the other stuff in the universe, is made up of combinations of the 118 different kinds of elements. There are so many different kinds of matter because atoms are like Lego blocks. They can fit together with other atoms to form bigger pieces of matter. Whenever two or more atoms join together, they create a molecule. Molecules are formed as a result of a chemical reaction between two or more atoms. In a chemical reaction, the atoms of the original substances are rearranged to form new substances that have different properties from the original substances. There are a couple of clues to look for to determine whether a chemical reaction has occurred. For example, a change in color or odor can be a sign that a chemical reaction has taken place. Also, if a gas forms when two different substances are mixed together, a chemical reaction has occurred. Conserving matter. Chemical reactions occur when two or more atoms interact. The effect of this interaction is that the atoms are rearranged to form new molecules. However, the total number of atoms does not change in a chemical reaction. The mass of any one element at the beginning of a reaction will equal the mass of the same element at the end of the reaction. This is called the conservation of matter. It states that atoms are never created or destroyed during a chemical reaction. They are rearranged to form new substances. For scientists to measure that matter has been conserved, they must conduct the chemical reaction in a closed system. In a closed system, matter is prevented from being added or removed from the system. In contrast, in an open system, some of the mass is transferred to the environment, which is impossible to measure. Matter has different properties depending on the number and different kinds of atoms that make it up. A property is an observable or measurable characteristic of matter. Properties help scientists classify and describe different kinds of matter. Properties include texture, flexibility, color, mass, volume, temperature, and odor. For example, scientists can use color to describe an object. Color is an observable property. From space, Earth is green and brown from the land, blue from the oceans, and white from the ice caps and clouds. Properties can also be measurable. Measurements are an important part of science. Scientists use the metric system, which communicates measurements of mass and distance in units, such as grams and meters. Mass is an example of a measurable property. Mass is a measure of the amount of matter that makes up an object. It increases as the number and size of atoms increase in an object. It is measured in grams. Whether or not a substance is a solid, liquid, or gas is another property of matter. This is called state of matter. Earth's atmosphere is made up of a mixture of gases. Gases are different from solids or liquids because of the amount of heat present. The atoms in gases are far apart and move with a lot of energy. As a result, a gas takes the shape of whatever it is in. It will spread out to fill all the space it is in, no matter how big the space is. In liquids, there is less available heat than in gases. The atoms in a liquid are close together but can slide past one another. This is why liquids flow, taking the shape of their container. The water in oceans is an example of liquid water. Solids have the least amount of heat. They do not have enough energy to move past one another. As a result, solids hold their shape because the atoms that make them up are tightly packed together. They hold their own shape until something changes them by force. Earth's land is an example of a solid. Remember that cause and effect describes the relationship between events or things, where one is the result of the other. For example, when the right amount of heat is added or taken away, it causes a substance to change state. When a substance changes from one state to another, it is a physical change. In a physical change, the atoms and molecules that make up the substance do not change. For example, if you leave an ice cream cone outside on a hot summer day, it will melt. The solid ice cream will gain heat, causing it to turn into a liquid. However, the ice cream will not change its chemical structure. It will still have the same properties. It can also turn back into a solid when enough heat is removed. Don't forget to check out the 5.1 review question video.